Welcome to Interface Studies. My name is Saleh. There is no shortage of takes on AI, prompts, taste, and which roles will survive when it comes to design. Most of that commentary, in my view, loops back on itself and lands nowhere useful. If anything real is changing, we have to start with a more uncomfortable question. What has being a software designer actually meant, commercially, for the last 30 years? Because the answer is less flattering than the profession likes to admit. And I'm saying this as a designer. And understanding it is the only way to see what is actually at stake now. Now, this is not a complete theory on design or on what's happening now or even what will happen later. It is a collection of observations from a decade of watching design roles, being in them, using tools, learning about them, and all the expectations that mutate in real commercial settings. At the core of everything, what AI is doing, I think, is just revealing paradoxes. Paradoxes that have been ignored for a long time within the industry. Over the past several decades, design accumulated a cluster of distinct roles. The information architect organized content so people could find it. The interaction designer specified what happens when a user acts, triggers a state, or hits an error. The visual designer handled hierarchy, type, color, contrast, and perception. The UX designer worked on flows and a bit of interaction design. The UX researcher produced evidence that you cannot get by just looking at the screens. These were genuine disciplines with their own methods and bodies of knowledge, but they did not emerge from a planned profession. They emerged because companies needed particular kinds of labor, and the market prized those as separate skills. Each title was at root a purchasing decision, a way to buy a specific kind of thinking. When mobile raised the commercial stakes and interface quality became legible as a competitive advantage, companies needed to move faster and hire more efficiently. The answer was the product designer, one person who could handle structure, interaction, visual design, and prototyping, owning the problem end to end. In many places, UX designers stayed on for a while, combining information architecture, interaction design, and sometimes research. But over time, the product designer role expanded until it was expected to cover almost everything, probably with the exception of research. Quietly, though, the specialist theories were collapsed without being replaced. The product designer did not magically inherit the depth of an information architect, the rigor of an interaction designer, or the evidential discipline of a researcher. They inherited the expectation of covering it all. That is strictly within the commercial settings. Their knowledge is still useful, but it has to be applied somewhere. And for the majority of how everything works, it's about work, it's about clients. The knowledge that has accumulated inside each role was now assumed to be present without being formally required. That was a compression, and compressions always have a cost. One notable counterexample within commercial settings was Quora, which required designers to write production code. The reasoning was simple. Designers should own the path from concept to implementation without depending on handoff. It was an honest response to the translation gap between design and engineering. But it also required a smaller, more selective hiring pool. It never became an industry norm because the industry and the way everyone was trained was to separate between design and engineering. Here where we come to tools. Design tools were never neutral. Every tool encodes a theory of what the design problem is. And the tools that win commercially are the ones that match what companies want designers to do. Within software design, Photoshop was for a while a tool for making things look finished. Sketch, which launched in 2010, was the first tool built specifically for interface design. Vector-based, artboard-driven, built for screens. It matched the product designer model closely: fast visual work, UI composition techniques, focus on canvas. Then came Figma in 2016. It changed the premise a bit. While keeping the canvas, it wasn't just a better sketch. The multiplayer infinite canvas turned design into a shared live space. Design was no longer a file to pass around. It was more of a space where designers, product managers, engineers, and stakeholders all stood together, shared the same resource. Shared component libraries turned design systems from documentation into living infrastructure. Figma's successive investments later on, like shared libraries, smart animate, interactive components, variables, and conditional logic, rewarded systematic spatial thinking. You built logic before you saw behavior. You reasoned about how states propagate through a component hierarchy. At its best, Figma could host the kind of reasoning interaction design had always demanded. Inside a tool, everyone could see. Now, because Figma was structurally successful, it became not just the dominant tool, but the dominant vocabulary. Components, variants, auto layout, all of these became how designers think about UI, not just how they represent it. An entire generation learned design inside Figma's mental model. That matters because Figma's model is not anyone else's model. It is not React's model. It is not UIKit's model. It is Figma's own spatial abstraction of an interface. Software engineer Joel Spolsky called this the law of leaky abstractions. Every abstraction eventually fails to conceal what it's built on. And when it fails, the person relying on it has no framework to understand why. That is exactly what happens when a Figma trained designer encounters a browser that doesn't exactly match their frame, or a Swift UI component that behaves slightly differently from an auto layout frame. The abstraction holds until it doesn't, and there's nothing underneath to fall back on. The separation of the roles made this a law, while the abstractions continued to shape professions. This consolidated Figma's position further. Figma hosted the system. Figma was the source of truth. Every hour invested in structuring a design system inside Figma deepened their lock in, not just commercially, but cognitively as well. Thinking about design meant thinking in Figma's terms. Designing for web, iOS, and Android simultaneously is where Figma's unified language did its most visible work. One vocabulary for responsive behavior, one set of components with platform specific variants. There is a real value there, but it also meant the vocabulary had to serve all platforms at once, which is to say, it served none of them precisely. It's beyond the skill here. It's about how much you invest in this tool to be able to compensate for this vocabulary problem between what is abstracted and what is native to the platform that you're working with. The unified surface in Figma obscured those differences instead of resolving them. Figma continues to work on ways around this, especially now with the arrival of AI. But even before AI, this tooling landscape resolved itself by attrition. Every few years, a new tool proposed a better vocabulary. Origami Studio or Play are good examples. Each embodied a theory of the design problem: native fidelity, animation, prototyping depth, platform realism, and many other things. Each eventually lost. None became the canonical way design should think. Figma was able, through this array of features, to become the source of design vocabulary. But this changed with AI. They're now keeping up. AI-enabled design tools reopen that question, but at a different layer. Tools like Magic Path, Google Stitch, and newer AI driven prototyping and system tools are not just proposing a new canvas vocabulary, they are proposing a theory of AI itself. What kind of generation matters? Where AI should sit in the workflow? What counts as source of truth? And how the system should be specified so that generation can work. These theories are competing in a commercial landscape. Each tool implicitly claims our way of framing AI's role in design is the one that will actually work at scale. Some lean towards preserving the canvas and layering AI onto it. Others bias toward code first, treating design systems and component registries as the model's primary context. Paper, Stitch, Magic Path, and similar tools all place slightly different bets on questions like the following. Is the canvas still the central object, or is it a view onto a code level system? Is the design system a Figma library, a registry in code, or a hybrid graph of components and behavior? Where does specification live so that AI can read it? In the age of generation and agents, the tooling question is more open ended than it has been in a long time. Generation has a unique ability to speak directly in code rather than through a visual abstraction. However, that promise comes with a large caveat. It depends on the language used in prompting, the model, the structure of the design system, the long term organizational habits around documentation, and even shifts in how teams think about responsibility. It is too early to say which theory of AI in software design will win, or even whether winning looks like one tool dominating. What is clear, though, is that tools are now refining not just a theory of design, but a theory of how AI should participate in specifying and building systems. That question is far from settled. It is having real consequences on the design profession from a commercial perspective, because that is affecting how designers are hired, what they should be trained for. The commercial pressure and the commercial thinking in companies will also shape a new kind of a labor market. And again, it is far from settled because there's no one clear answer. The probabilistic nature of AI makes that harder. It is even harder than using lots of abstractions, say with Figma. There was a source of truth that is stable, clear, and there's a clear responsibility for it. This is what will take us to talk about generation, these unspecified states, and the front end drift. AI generation is broader than prompting, and any conversation that treats it as merely a prototyping trick is already behind. You can now take a rough sketch and produce a working component. Agent-based workflows can infer flows from a description and generate the navigation. Systems like V0 and similar tools generate React and Tailwind from natural language and are moving toward AI-native design systems, where the component registry becomes the model's primary context. Figma, as I said earlier, is trying to do something similar while preserving the canvas. Stitch and Magic Path and others are exploring the boundary between canvas and pure generation. But whatever the tool, the canonical source of truth is shifting. And it is shifting from the designer's spatial artifact to a code based component structure, a code that is generated but no one wrote it. In Figma's model, the designer's file was upstream of the code. In a registry model, the designer's real contribution is the registry itself. This is the components, their states, and the documented decisions they encode, and then generation produces the screens. Here, the last decade of front end experience becomes directly relevant. The classic handoff model, designers produces file, developer translates it. It trained many developers to be translators rather than co thinkers. The design skill exists less and less in someone who's just asked to translate what exists and under time pressure. Unspecified states were filled by whoever was the closest to the ticket. Edge cases were resolved however was technically convenient. Again, this wasn't negligence. It was a structural consequence of a model where the specification ended at the artboard. Everything left open became the developer's problem by default. Over years, a lot of real interface thinking moved from design into development. That happened informally, through defaulting rather than deliberate decisions. And I think AI generation is that model's logical conclusion running faster. It fills unspecified states by defaulting to training data, to what the component library does out of the box, to statistically common patterns. Models are getting better at coverage, but they still do not care. And this matters. They don't inherently ask about loading, failure, empty states, long term use, or recovery paths. They just produce something. Someone has to think of this before. What has become clearer with the popularity of agents and skills is that most of the work is now in specification, defining a state space and a set of constraints that generation can operate within. Multiply by unspecified states, and you multiply the place where generation will quietly guess. This is even being applied to the developer world, but I'm focusing specifically on design. Who is a software designer then? If generation can create components, flows, and patterns from descriptions, the question of what a designer is for has to be answered differently. Not in terms of their relationship to a tool, whether they use Claude or Codex, but in terms of what they are the custodian of. Generating screens is cheap. Generating components and flows is increasingly straightforward. What no generation tool can supply is an explicit, maintained, legible theory of what a system is for and the capacity to hold that theory consistently enough to know when something generated violates it. This is not about prompting skills. Prompting is a delivery mechanism. The real question is what you are delivering. As AI agents can generate a component that encodes a design decision, it cannot, on its own, notice 6 weeks later that two subsequent components contradicted that decision. It cannot hold the principle behind a choice and apply it to a situation that was never explicitly described. It cannot detect when a specification has drifted or when the system has accumulated enough inconsistency that it has quietly stopped making sense. It will produce something. Whether that something is correct depends entirely on whether there is an explicit reference to evaluate it against, and whether anyone in the room understands that reference well enough to apply it. The specialist roles that were compressed away, information architects, interaction design, UX research, were each, in practice, a person keeping a theory legible by defending its consistency against commercial pressure. When those roles were absorbed into the product designer, that function did not disappear. It became invisible, carried informally in the heads of experienced practitioners, and enforced through reviews rather than infrastructure. Now, with generation tools producing output faster than any team can review manually, invisible theory is not sufficient. What distinguishes a designer now, in my view, is not whether they work on a canvas or in a prompt. It is whether they are the person who holds a clear, documented, current reference for why the system is the way it is, and who can use that reference to identify when generated artifacts are wrong. Not just visually wrong, but wrong in the sense of contradicting a decision the system depends on. That reference has to exist as infrastructure. Generation will either use it as context or ignore it if it exists only in someone's head. As far as the model is concerned, undocumented intent does not exist. This is very close to systems engineering, and it is closer to it than visual design has traditionally trained people for. It is the work of making intent legible not just to users, but to the process of making the product itself. Whoever owns the design system, the component registry, the tokens, and the documented interaction decisions need to own them as theory, not just as a library. Owning that will never be glamorous work. And the interaction designer's most valuable work was often a set of annotations nobody read until something broke. The difference now is that generation will not pause to ask. It will continue producing. The only question is whether anyone can tell if the output is right. The generation speaks the platform directly. What designers bring is the theory, held not just as instinct, but as infrastructure. The labor market is following the same logic it always has. The commercial pressure that compressed 5 specialist roles into one product designer is now compressing further. Design hiring dropped sharply from 2022 onwards, and AI generation arrived into contraction, not expansion. Whether that is right or wrong is almost beside the point. Companies are discovering now that they can produce more visible output with fewer people. The mid level product designer, already carrying responsibility they were never formally trained for, is being squeezed from both sides by AI and code generation below, and by more system focused, code fluent roles above. The purchasing decision has not changed in character, it has only become more aggressive in its logic. The investment that survives is unlikely to be a mastery of a single tool or of prompting. It is in the capacity to build and maintain a reference, to specify the full state space of a system, to document the decisions behind components, maybe generate them. But what matters is reading them, understanding them, and being able to bring them back, not just from an appearance perspective. One needs to hold those decisions consistently enough to catch when generated artifacts violate them. This is the work that remains scarce, and the work that generation, by itself, cannot do.